Okay, guys, I hope you guys are having a great day, but let's get started on today's video. If you recall, last week we talked about relations and the domain and range of relations. So we're going to use what we learned last week for this week, and I just want you to remember that the domains of a relation were all the x values, and the ranges of a relation were all the y values. So, for example, if I had the relation 4, 3, 3, 2, -1, 0, this would be my relation. And then my domain would be all of the x values in order. So I have -1, 3, and 4. And then my ranges are all the y values in order. And that would be 0, 2, 3. Okay, so today we're going to decide if when you're given a relation, right here, if it's a function or not. So let's get started. Here's your vocabulary. A function is any relation where each domain is paired with only one range. So each x value has to have only one y value. And here are the different terms for x. And here are the different terms for y. And these are the different ways that we have to remember things. For every input, there's an output. That means for every x, there is one y. For every independent variable, there is exactly one dependent variable. So for every x, there is exactly one y. For every domain, there is exactly one range. Again, for every x, there is exactly one y. So if I were to draw a table of x's and y's, each x has one y. Does not have two, it has one. And that makes it a function. Okay, so all of this goes into the vocabulary box on your notes. Please make sure you have all of that. I will be checking. Think of it as a vending machine. So, like I said, for every x, there's only one y in a function. That means that if you were to go to a vending machine and push C4 on the vending machine, you are going to get Chex Mix right there. You can't get anything other than Chex Mix because every one of these things only has one thing. It's only one code. So you're going to get exactly what you put in. So you put C4, you get Chex Mix. You put in C2, you're going to get the famous Amos. Okay? You only can get one thing from each thing. By the way, for those of you who really like to have a lot of notes and like to use your resources, you might want to print this page. It will be on the website in PDF form. Okay, let's review. It's a function if every input or x value has one output or y value. And you can determine this by two different ways. The first way we're going to look at is the table. So I've got a -2 here, and the output for that is 4. Remember, the x is the input, and the y is the output. And for -1, I have 1. For 0, I have 0. For 1, I have 1. For 2, I have 4. Every single x value has only one y value. If it has more than one, then it's not a function. So more than one y value equals not a function. The other way we can look at it is this graph, and we're going to go over more than this later, but you can do the vertical line test, and remember vertical line is up and down. And if it only hits the graph one time, the points that are graphed here, then it's a function. If it hits more than one time, like say it was a circle here, and it hits here, and it hits here, then that would not be a function. Okay? So let's look at here. We have 3 examples here. This one is a function because Amber only has blue, Tim only has red, and Kayla only has green. So that is a function. Because each one of these x values, remember domain is x and range is y, the x's only have one y value. So that makes it a function. This is a function. Alfonso only has blue, Melina only has blue, and Chen only has green. Each x value only has one y value. Now these two share the same y value. That's okay, because Alfonso still only has blue, and Melina still only has blue. If Alfonso had blue and green, then it would not be a function. But because he only has blue, that means, yes, it's a function. Check this one out. This one's not a function because look at what I just said here. Elena has blue, but she also has red. That right there, the fact that Elena has 2 things over here, that makes it not a function. Now Haley only has red and Tony only has green. If Elena only had blue, then it would be a function, but because she has blue and red, that makes it not a function. So if I were to have some x and y's here, let's say I had x and y's, I had 2 is 4, and 3 is 4, and 0 is 1, and 2 is -1. Check this out. I've got a 2 here and a 2 here. This 2 says y is 4, but that 2 says y is -1. That would make it not a function because you've got 2 different things here for 2. You've got a 4 and a -1. And because you've got 2 different y values for that same x value, because that didn't change. 2 is still 2 down here. But because you've got 2 different y values for that same one, that makes it not a function. But if you had this instead, if you had 2 and 4 and 3 and 4 and 0 and 1 and 2 and 4, now the 2's are the same, right? 2 is 4 here and 2 is 4 here. That makes it a function because it's exactly the same. Okay? Let's check these out. Let's see if we can make that a little bit bigger. There we go. Okay. All right, let's check this out right here. This one says the 1 is linked up to the C, the 5 is linked up to the A, and the 8 is linked up to the B. Oh, by the way, all of these go into your sample or your practice problems. Box 1. All of these. You just draw the pictures and fill it in, okay? So 1 is linked up to the C, 5 is linked up to the A, 8 is linked up to the B. All of these x values have only one y value that they're linked up to. That makes it, yes, a function. Uh-oh. I've got 0 linked up to the -2, and I've got 0 linked up to the 1. That right there makes it not a function. The rest of these are only linked up to one thing. The 1 is linked up to the 2 is linked up to the 1, and the 3 is linked up to the 4. The rest of them are okay. But because 0 is linked up to 2 different things on the output, or the y, that makes it not a function. Let's look here. 1 is linked up to the 1, 2 is linked up to the 2, 3 is linked up to the 1, 4 is linked up to the 4, but 4 is also linked up to the 3. So that one right there, it's linked up to two things, so that makes it not a function. Let's look down here. -1 is linked up to the 4, 0 is linked up to the 7, 2 is linked up to 3, 3 is linked up to 3, 4 is linked up to -2. Every one of these x values is linked up to only one y value. Now this y value is linked up to two of those, but that's okay. It can be linked to two different x's. It's just that the x cannot be linked to two different y's. So yes, that is a function. Okay, let's look at this one. -3 goes to -1, -2 is to 0, -1 is to 1, 0 is to -2, 1 is to -1, 2 is to 0, and 3 is to 1. I have nothing over here that repeats itself, so that would make that yes a function. Okay, now over here I've got a 4 and a 4 that repeats, and a 3 and a 3 that repeat, and a 2 and a 2 that repeat, and a 1. So we have to make sure they all are the same. So let's do the 4s first. The 4 goes to a -3 here, and the 4 goes to a +3 here. That means that 4 on the x value is going to two different things on the y value, a -3 and a 3. So the 4s make it not a function. Let's just check the rest and see if they do the same thing. 3, you've got a 3 here and a 3 here. This 3 goes to a -2. This 3 goes to a +2. That's two different y values for the same x value. So that's going to make it not a function also. Now we've got a 2 here and a 2 here. And this 2 goes to a -1 and this 2 goes to a +1. So again, I've got the same x value here, but I've got different y values here that they both link up to. So that also would make it not a function. Okay? Can only link up to one thing. Now, let's just check that out. If that had looked like this, if you had your 4, 3, 2, 1, 0, but there was no 0 there, 2, 3, 4, and you had the same values, -3, -2, -1, 0, -1, -2, -3. See how these 4s, they have the same thing that matches up on that side? And these 3s, they have the same thing that matches up on that side. And the 2s, they have the same thing that matches up. That would make it yes a function. But because these things here don't match up, that is not a function. Okay, the vertical line test. Now this is what I was talking about earlier. And you're going to want to put this in the steps. And let's check out the other one. Do you want me to put those in the steps? You should put these in the steps also, steps box. Okay. Okay, so these are in the steps box. And basically what the vertical line test is, says that here's a bunch of points that I had in my relation. And I connected the points by drawing a line, connecting the dots, right? Now, if I were to take a vertical line and draw it anywhere on here, doesn't matter where it is, I could draw a million of them. If any vertical line touches this relation more than once, then it's not a function. But look, this only touches it once here, this only touches it once here, 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 once here. No matter where I put a vertical line on that relation, the vertical line is only going to touch that relation one time. So that would make that yes a function. Now let's look at these relations. Let's say I had this point here and a point here and a point here and a point here, and I connected them all by drawing a circle. Now if I do some vertical line tests, I might only touch it once there, and I might only touch it once there. But look, if I do that one, it touches two places. That makes it not a function. If I do that one, it touches two places. That makes it not a function. Two places, not a function. Now, if you remember when we did the tables, you could only have one y value for every x value, right? So here, you've got two different y values on this vertical line. Check that out. You've got one y value here, that's 1, 2, 3, 4, 5, 6, 7, that's a negative 7. And then you have another y value here that I'm sorry, that's a positive 7. That I'm going to guess is probably about a negative 7. So that would make it two y values there. We do the vertical line because vertical lines are all the y values, right? The horizontal lines are all the x values. So, and remember we said we can only have one y value for every x value. And here we've got two y values, so that makes it not a function. So if it hits your relation more than one time, then it doesn't work. So let's do some practice ones like that. Okay, we can go ahead and if this right here is a relation, or even if this right here is a relation, the blue and green, we can do a vertical line test, and it hits that 3 times. So that would not be a function. This one, let's see, let's do several different ones. Okay, that one only hit once, that one only hit once, and that one only hit once. So that would make that yes, a function. Let's try this one. We'll do a couple different ones. Okay, that only hit once, that only hit once, that only hit once, and that only hit once. So that would make that yes, a function. Okay, again, let's do several different ones just to make sure that we're right. That one hit once, that one hit once, and that one hit once. So that is yes, a function, because each one of those vertical lines only hit once. Now let's do several here. That one hit twice, so we know automatically. What if I had only done one there? I wouldn't even have known. That's why I do several. Because check that out. These two, they hit twice. That one only hit once. But it's still not a function because I've got these two vertical lines that hit twice. Okay, and I can tell right away by doing that one, that hit twice, so that would not be a function. Okay, so that's how you tell whether or not it is a function. This is the other part of this lesson, is independent versus dependent variables. And remember at the beginning when we had our chart, we had all the x's and the y's and the different things to call them. We had input, we had domain, and the other one was independent variable. So your independent variables are all your x values. And for y values, we had output, we had range, and we had dependent variable. So all your dependent variables are your y values. It's just another way to call them, okay? Okay. So remember the other day when we did the tables, the functions tables, and we had our x values here and our y values here, and we said if x is 1 and x is 2 and x is 3, and the equation is x plus 2, if we do that, we substitute that in 1 plus 2, we would get a y value. And if we substituted this x in here for the equation, we would get a y value. Sorry, that should be plus. And if we substituted this x in here, we would get a y value, and then you'd have your ordered pair would be 1, 3, and 2, 4, and 3, 5. Okay, this is the same thing right here. It's the same as this. This is just saying that the independent pieces are the x ones here, and that the dependent ones are the y ones. And in order to get the y's, you have to have the x's. So if we look at this example right here, we can see Mike is buying pies for a party, and the price of one pie is $4, right? Make a table of ordered pairs in which the x-coordinate represents the number of pies. So x equals number of pies, and the y represents the cost. Y equals the cost. Okay, where the x values are represented by the number of pies of 4, 2, 3, 4, and 5 pies. So really we could make a table here, right? And for our x values we said the number of pies. So the number of pies for 2, 3, 4, and 5 pies. So 2, 3, 4, and 5 pies, right? And we want to know the y value, the cost. What's the cost for 2 pies? What's the cost for 3 pies? What's the cost for 4 pies? What's the cost for 5 pies? So what you would do is you would take your x and you would multiply it by 4, so 4x, because it's $4 for 1 pie, and that's how you would do it. So you'd have 4 times 2, so your y would be 8, and you'd have 4 times 3, and that would be 12, and 4 times 4, so 4 pies would be 16, and 4 times 5 pies would be 20. Now check this out. We also said that the independent variables was x. The independent variables was x. So our independent variable is the number of pies. So if you are asked what the independent variable in this problem right here is, it is the number of pies. And we also said that the y value is the dependent variable. So your dependent variable is the total cost. So if you are asked what the independent variable is, it's the number of pies, be your x's. Your dependent variable would be the total cost, or the y's. Okay? Let's try some more examples. You should put this in your steps box also. If you have run out of room in your steps box, then you can go ahead and you should have anchored your notes page into your notebook, so you should have some line space behind it where you anchored it to. So go ahead and put your extra notes on that space there. Okay, this should be in box practice problems, and this should be number 3. And I forgot to tell you earlier, but the vertical line test ones, these should be in practice box number 2. Sorry about that. All right. So it wants to know what's the independent variable and the dependent. And we remember that the independents are the x's and the dependents are the y's. So we have to look for what's x and y. It costs $3 per hour to park at the Wildwood Amusement Park. Make a table of ordered pairs in which you represent the total cost for 3, 4, 5, and 6 hours. Well, 3, 4, 5, and 6 hours, we know that those are our x values. Because if we did a table, we would put the number of hours over here, 3, 4, 5, and 6, because the number of hours, it makes a difference on what we pay. If we only go for 1 hour, we only pay $3. If we go for 2 hours, we pay $6. This amount changes. So you know your cost is going to be over here. It's going to be y, right? And then you would do 3 times x to find your total cost for each one. So your independent variable equals your hours on this one, and your dependent variable equals your cost. Okay, and that's all it's asking, so I'm not going to fill in the rest of this. A movie rental store charges $3.95 per movie rental. Make a table of ordered pairs in which you represent the total cost for 1, 2, 3, or 4 movies. And again, you've got, if you were to make a table, you have your x and your y value. Your x's are how many movies you rented, because that is going to get multiplied by how much it costs in order to get your total cost. So you've got 1 movie, which was $3.95, and you've got 2 movies, which if you multiplied $3.95 times 2, you would get a y value, and 3 and 4. So I know now that my independents are my number of movies, because that is what affects how much it costs, and the dependent is the total cost. Okay? Because that would be my y value. And let's try one more example here, or 2 more. And these are going to go in practice box number 4. Okay, I've got at a vacation resort, you can rent a personal watercraft for $20 per hour. That's for 1 hour. Make a table of ordered pairs in which you represent the total cost for 1, 2, 3, or 4 hours. So if I were to do my table, what's going to go on the X values? Those are going to be my hours. How many hours it costs? And it's $20 per hour, so it would be 20 times X. And I would do 20 times 1, and it would give me $20. So my independent variables are my X's, that would be my hours. And my dependent variable would be how much it costs. So that would be a cost. Okay, a company car can manufacture 825 small cars per day. Make a table of ordered pairs in which you represent the total number of cars produced in 1, 2, 3, 4, and 5 days. So if I were to draw my little table, and I put my X values and my Y values, I've got 1, 2, 3, 4, and 5 days at 825 per day. So 825 cars times X. So I'd have 1 times 825 would give me, for 1 day, 825 cars. If I did 2 days at 825 per day, I would have 1,650 cars for 2 days. And you would keep going. So your X values were the amount of days, and your Y values were the amount of cars produced. So this is your independent variable, and this is your dependent variable. Okay, if you have any questions about anything that we did, I need you to please make sure that you come in prepared with questions. And we are going to do some more practice ones when you come into school on Monday. So if you don't 100% get it, that's okay, but you need to make sure that your notes are complete, and if you have any questions, you need to be prepared to ask them. Have a great, great night.